We are the super sharp life in the known universe. I mean, imagine that we're the fundamental place where there is information in this world. Space specialists generally throughout the world are in staggering awe of this moderate revelation. The James Webb Space Telescope has captured the unpretentious sparkle of city lights a mind-blowing 7 trillion miles away from Earth, outperforming all presumptions. This staggering achievement does more than simply broaden our perspectives regarding what we know of the universe. The theory goes crazy as specialists pore over the data, searching for hints that could unlock the secrets of these clandestine sublime reference points. The ideas are astonishing, providing proof that we are not alone in the universe, that the universe teems with life and development far beyond our capacity to grasp. Is it possible that these faraway lights indicate the presence of extraterrestrial societies? What does this mean for our understanding of the likelihood of life in the universe beyond Earth? Consider this as we research how the James Webb Telescope saw city lights 7 trillion miles away. Sent into space on Christmas Day 2021, the James Webb Space Telescope intends to surpass the deeply grounded Hubble telescope in capturing especially sharp photos of recently discovered superb particles, planetary systems, and more. A consistent goal of the JWST is to study the formation of the first galaxies by looking into the faraway regions of the universe. This is possible because the journey time of light throughout our universe is billions of years. When the JWST collects light, it sees these things exactly as they were billions of years ago. Astronomers measure distances in light years, which is the maximum distance light can travel in a year. To illustrate this, the telescope's initial field image, presented on July 11, 2022, by U.S. President Joseph Biden from the White House, was a significant field picture. While the Hubble Space Telescope focused on a single region of the sky for 10 straight days starting on December 18, 1995, the selected area was just a small spot making up around 1/1,000,000th of the entire sky. Most of the 3,000 previously hidden objects found by Hubble were galaxies billions of light-years away. The JWST's significant field covers a similarly small sky region. The universe SMX 723 is 46 billion light-years away. The more distant galaxies behind it are enhanced by its strong gravitational field. The foundation galaxies are distorted into enormous arcs where the gravitational field is strongest. In one frequency, it was confirmed that it took a distant galaxy's light 13.1 billion years to reach the telescope. The light being emitted stretches as the universe expands, depending on this point. The JWST's primary images have extended visible light from their stars into the infrared. Cosmologists can clearly compare JWST and visible light photos of nearby galaxies taken by Hubble and other telescopes by gathering data at those frequencies. This will show how galaxies evolve over grand periods, developing and setting into the formations we observe today. More stunning than the sheer number of galaxies in the JWST's first significant field image is how quickly it was captured, in just hours, rather than days. Everywhere it looks, it finds galaxies. Galaxy clusters are not the only objects acting as enhancing focal points. Researchers used the JWST to capture an image of several galaxies designated VV1 to 191 so they could study how the light from one of the pairs altered as it passed through the other. The results of the assessment will reveal the properties of the intervening cosmic dust, and it appears the JWST may have already made a striking discovery: light years outside our solar system. The announcement of the possible discovery of auroras on a so-called brown dwarf came from the official JWST site. The lack of a host star and the frigid temperature make it challenging to pinpoint where the energy in the upper atmosphere is coming from. Nevertheless, the article suggests that the auroras are likely emitting methane. An aurora on Earth is created when energetic particles from the sun are captured by our planet's magnetic field. These charged particles then make their way into Earth's atmosphere through lines of magnetic fields near the poles, where they collide with gas particles to produce a beautiful light display known as the aurora borealis. Jupiter and Saturn have comparable auroral characteristics due to the solar wind. However, the brown dwarf W11D935 has no star to orbit, so its auroras remain a significant mystery. The focus continues to be on Proxima Centauri and Torb, just 4.4 light-years from Earth, where researchers are identifying the presence of water on the exoplanet. The possibility of life on these planets can't be ruled out. Just last month, the JWST observed another massive black hole in formation, consuming everything around it. This discovery is 40 million times as massive as the Sun. The JWST has also considered another very large black hole that has existed since the beginning of the universe, likely generating exciting news. This monster is rapidly consuming everything in its immediate vicinity, leading the discovery. Dr. Lucas Anami and Professor Manade Insight Zitron from the Bond School report that this massive black hole is approximately several times heavier than the Sun, making it a colossal entity in comparison to the galaxy it resides in. Fortunately, it is not near Earth or our neighboring solar system, but rather an astonishing distance of 129 billion light-years away. It is, however, moving closer, with the black hole consuming everything around it at an accelerated rate. The redshift indicates that it is surrounded by a thick veil of dust that prevents light from passing through. When the JWST began transmitting its initial data, scientists were thrilled to find 3 small AR objects with a dark red glow, initially mistaken for a quasar-like object with exceptionally massive black holes at the centers of galaxies that are continually gathering material due to their red spot appearance. The entire galaxy's brilliance couldn't reasonably be confined to a spot no larger than a present-day star cluster. We were able to obtain very precise size measurements due to the source's gravitational lensing. Even when all potential stars are compressed into that small region, the black hole represents only about 1% of the galaxy's total mass. The discovery of similarly massive black holes in other early galaxies has provided insights into the development of both the black hole and the host galaxy, as well as the relationship between the two, which is still largely unknown. If these enormous black holes formed from stellar remnants or from primordial material falling into black holes, astronomers have no definitive answer. Additionally, in the images sent back to Earth, the James Webb Space Telescope is uncovering other intriguing phenomena. We continue to enjoy exploring space and being captivated by the amazing lights of planets and stars floating across the universe, light years away. However, the JWST allows us to see much beyond what was previously possible. For example, a question mark-shaped feature in space was recently detected. For at least 20 months, the JWST has been orbiting space, sending back images of its findings using its state-of-the-art near-infrared camera. Recently, answers have been provided to a somewhat unusual finding in one JWST image focusing on something entirely different. The image was released by the European Space Agency, showing 2 energetic stars about 1,470 light-years from Earth. However, there is a small orange mark at the bottom of the photo resembling an upside-down question mark. The small image is not microscopic by any means. Indeed, it's quite large. The question mark was detected while observing the formations of young stars named Herring Legend 46 to 47, surrounded by immense clouds of dust and gas, with ages spanning several thousand years. The question mark shape itself might appear to be merely due to the two-dimensional image captured by Webb from its particular viewpoint. At this point, we do not have the faintest idea what it is, and without further investigation, we may never know. Nevertheless, the discoveries have been reviewed by experts, suggesting it is likely a distant galaxy or possibly galaxies interacting with one another. The distorted question mark pattern could be a result of their interactions. Perhaps we have never seen anything like this before. To determine its identity with any level of certainty, further investigation is essential. With the abundance of distant discoveries made by the JWST, there is a surge of new research questions. Everyone's attention is now focused on a particular set of Earth-sized planets that could potentially harbor extraterrestrial life. The hope is that this might resolve the long-standing question of whether high-level extraterrestrial life exists in the universe. Despite the high probability that such beings exist, it may finally be settled. Where are these planets? Roughly 40 light-years from Earth and within the nearby star cluster is a star known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to find habitable planets, NASA considers a variety of factors beyond planet size and distance from its star. A more robust approach would be to analyze the overall compositions of these planets' atmospheres. This would allow researchers to determine whether a planet is habitable. The Infrared Spitzer Space Telescope, part of NASA's space exploration mission, helps observe the 7 rocky exoplanets orbiting a similar star known as TRAPPIST-1. Recently, the James Webb Space Telescope has assessed the temperature of TRAPPIST-1b, one of those planets. The JWST has consistently provided groundbreaking revelations since its launch, and this discovery is certainly the latest in a series of record-breaking firsts. This is the first detection of light emitted by an exoplanet as small and cool as the rocky planets in our nearby solar system. No previous telescopes have had the capability to measure such faint mid-infrared light. Cosmologists were thrilled when they first studied the 7 TRAPPIST-1 exoplanets, as these distant worlds are Earth-sized and located in the habitable zone, the region where planets can have liquid water on their surfaces, given the optimal distance from their star. They